In this example, we'll be working with complements and supplements of angles. For an angle measuring 40 degrees, find the measure of its A complement and B supplement. Now for part A, a complementary angle adds up to 90 degrees. And therefore, we would say 90 degrees minus the 40 degrees, and that would equal 50 degrees. So the complement of 40 degrees is 50 degrees. Now, for the supplement, the angles would add up to 180 degrees. So for part B, we would take 180 degrees, and we would subtract 40 degrees, giving us a result of 140 degrees. So 140 degrees is the supplement of 40 degrees. In this example, we'll be working with complementary angles and supplementary angles. Find the measure of each marked angle in the figure. And you can see that we have a 90-degree angle here, which means that the two angles that we're dealing with are complementary, which means that their sum is 90 degrees. So we can write the equation 6x plus the 3x is equal to 90 degrees. And so then we would solve that equation for x. Let's do that here. So we have 6x plus 3x, which is equal to 9x, equals 90 degrees. And now we divide both sides by 9. And that gives us the result that x is equal to 10. Now that's x, but we need to find the actual angles. So the first angle, 6x, would be 6 times 10, which would give us 60 degrees. The second angle is 3x, so 3 times 10, and that would be 30 degrees. So our two angles are 60 degrees and 30 degrees. Now let's take a look at part B. Find the measure of each marked angle in the figure. And this time we have a straight line that's formed by the two angles, and therefore a straight line, which is 180 degrees, means that these two angles are supplementary. Their sum is 180 degrees. So we set up an equation which tells us 4x plus the 6x is equal to 180 degrees. And that's the equation that we'll solve for x. So let's do that here. 4x plus 6x equals 180 degrees. Therefore, 10x equals 180 degrees. We now divide each side by 10. And on the left, of course, we have x equals, and on the right, 18 degrees. But that x is just the value for x, not the value of the two angles. So we need to substitute that back in for x to find the actual measure of the angles. Let's start with the 4x. So that would be 4 times 18, which is 72, and it will be degrees. Now we do the same thing with the other angle, which is the 6x. 6 times 18, which will give us a result of 108 degrees. So the two angles measures are 72 degrees and 108 degrees. In this example, we'll be performing a calculation with degrees, minutes, and seconds. Perform the calculation. 51 degrees, 29 minutes, plus 32 degrees, 46 minutes. Let's set this up in the vertical format. So 51 degrees, 29 minutes, plus 32 degrees, 46 minutes. We're going to add those two together. 9 and 6 gives us 15. Carry that 1 over to here. And 1, 2, and 4 gives us 75 minutes. Then we do the degrees. 1 and 2 is 3. 5 and 3 is 8. But now we notice that the 75 minutes needs to be dealt with. That this is really the same as, of course, 83 degrees, then plus the 75 minutes is really 1 degree, which takes up 60 of those minutes and leaves us 15 minutes. So now we combine the 83 degrees and the 1 degree for a total of 84 degrees, 15 minutes. That would be the sum of those two angles. Let's take a look at part B. Perform the calculation. 90 degrees minus 73 degrees, 12 minutes. If we set this up in a vertical format, we would have 90 degrees and then 73 degrees, 12 minutes. And what that tells us when we want to do the subtraction is we're going to have to borrow. So we're going to rewrite this as 89 degrees, 60 minutes. That's the equivalent of 90 degrees. But now we can perform the calculation, which is to subtract 73 degrees, 12 minutes. So here we have 10 minus the 2 is 8. We've borrowed from here, so it's a 5 now. Minus 1 is the 4, so 48 minutes. Now we do the degree measures. 9 minus 3 is 6. 8 minus 7 for 1. So the subtraction yields 16 degrees, 48 minutes. Convert 74 degrees, 8 minutes, 14 seconds to decimal degrees to the nearest thousandth. So to do this, the first part, the 74 degrees, is exactly the way we will leave it. It's the 8 minutes and the 14 seconds that we need to change. So this would be equal to 74 degrees, and now what we have to do is divide the minutes by 60 minutes. So this is going to be plus 8 divided by 60. And that's going to then convert this also to degrees. Similarly, we have to divide the 14 by 3,600 seconds, and that would convert the 14 seconds also to degrees. Now, either by hand or on a calculator, you can do each of these calculations. 8 divided by the 60 results in 0.1333, and it repeats, but we're rounding to the thousandths, so I can stop here. Plus, when we divide the 14 by the 3,600, we get 0.0039, and again, I can stop there. Each of these is still degrees, again, because we're going to eventually round off to the thousandths. Then, this is going to be approximately equal to 74.137 degrees. Let's look at another example where we're going to do a conversion. This time we'll convert 34.817, or 34 and 817 thousandths degrees, to degrees, minutes, and seconds to the nearest second. So here we begin with the 34.817 degrees, and we now rewrite that, and we know the degrees portion here, the whole number 34, stays as is. But now for the 817, we have to convert that into minutes and seconds. So, continuing along with the 34 stays as is, what we now need to do is multiply this first by 60 minutes. So, we would have 0.817 multiplied by 60 minutes, and so it'll convert that degrees to minutes. So this would be equal to 34 degrees, and then using a calculator here, this would be 49.02 minutes. We keep the 49 portion, and what we want to do is convert the 200ths of a minute into seconds. So this would look like, equals 34 degrees plus 49 minutes. And now we have to multiply the 0.02 times 60 seconds. So we would have 0.02 times 60, and that'll convert it into seconds. So finally, we have 34 degrees plus 49 minutes plus 1.2 seconds. Now remember though, we were to round this to the nearest second, and therefore this is going to be approximately 34 degrees, 49 minutes, 1 second. In this example, we'll be finding the measures of coterminal angles. Find the angles of least possible positive measure coterminal with the angle 908 degrees. So what we're looking for is an angle that's going to be greater than or equal to 0 and at the same time less than 360 degrees. Now what that means is from 908 degrees, we need to subtract a multiple of 360 degrees so that we end up with an angle between 0 and 360. And that multiple would be 2 times 360, so 908 degrees minus 2 times 360 degrees. Or in other words, 908 degrees minus 720 degrees, which gives us a result of 188 degrees. So 188 degrees is coterminal with 908 degrees. Let's look at another one. Find the angles of least possible positive measure coterminal with the angle negative 75 degrees. Now in this example, we want to end up with a coterminal angle that's between 0 and 360 degrees. So this time we're going to have to add some multiple of 360 to the negative 75 so that that result is between 0 and 360. So we will add simply 1 times 360. Negative 75 degrees plus 360 degrees. That gives us a result of 285 degrees. So 285 degrees is coterminal with negative 75 degrees. Just to give you an idea of the picture of this, negative 75 degrees would go like that, approximately. Negative 75. 285 degrees would come around this way, 285 degrees. Let's take a look at one more. Find the angle of least possible positive measure coterminal with the angle negative 800 degrees. So what we need to do here is add a multiple of 360 degrees to the negative 800 so that that sum is between 0 and 360. So what we're going to have to do is add 3 times 360. So negative 800 degrees plus 3 times 360 degrees. That would be negative 800 degrees plus 1,080 degrees. And that will be equal to 280 degrees. And so what we would say is that 280 degrees is coterminal with negative 800 degrees. In this example, we're going to analyze the revolutions of a circular object. CAV, constant angular velocity. CD players always spin at the same speed. Suppose a CAV player makes 480 revolutions per minute. Through how many degrees will a point on the edge of a CD move in 2 seconds? To begin this problem, we'll start with the number of revolutions it makes per minute, which is 480. But what we're interested in is converting that into seconds. So if we have 480 in 1 minute, then we would have to divide this by 60. So 480 divided by 60, which is equal to 8 revolutions in 1 second. So we have it into seconds now. Next, what we'd like to know is that we're actually looking at 2 seconds. And therefore, 2 times 8, which is 16 revolutions in 2 seconds. And then finally, we're interested in the fact that each revolution is 360 degrees. So we want to take the 16 revolutions, multiply that times 360 degrees. That gives us a product of 5,760 degrees in 2 seconds. And so that means that the point on the edge would travel 5,760 degrees in that 2 seconds.